In this video, I will be describing RS configuration for chiral molecules. First, I will describe what is the chirality. So, chirality is the property of handedness. It means when an sp3 hybridized tetrahedral carbon attached with the four different groups, such kind of molecules and its mirror images will not be superimposable. So that kind of molecules is called the chiral molecule. So in the first example, you can see this is a sp3 hybridized tetrahedral carbon and it attached with the CH3 group, chlorine group, hydrogen group and CO2H group. So this kind of molecule, when you take the mirror images, so that another molecule, so these two molecules when you just want to superimpose, it will not superimpose. So if non-superimposable mirror images of any molecules are coming, so that kind of molecules are chiral molecule and their relationship we can say that enantiomer. Enantiomer means opposite. Okay, so this kind the RS configuration notation uh, has been given by Can, Ingold, and Prilov. So these are the three scientists who has assigned the chiral molecule into the RS configuration. So according to their rule, according to this rule is known as CIP rules, Can, Ingold, Prilov CIP rules. According to the CIP rules, so in the tetrahedral carbon, the group attached, we need to put it into the priority order. It means you can see that here is a chlorine is attached to the tetrahedral carbon. Similarly, methyl is attached to the tetrahedral carbon. Hydrogen is attached to the tetrahedral carbon, and also CO2 is attached. According to that rules, so it based on the atomic number rule. The whatever the atomic numbers of that group will be high, and subsequent group, okay, subsequent atom will be high. So that will get the priority. So in this case, if you check the groups, the chlorine has the more atomic number compared to carbon and compared to hydrogen and other carbon. So after chlorine, you can see that if you see the other groups, the number 2 will be coming the CO2H. Why the CO2H will come? Because here, after chlorine, you can see the more atomic number is the carbon. But in case of CH3, after carbon, there is a hydrogen is coming. But in case of CO2H, there is a 2 oxygen and 1 phantom oxygen. It is coming with the carbon. It is attached with the carbon. So after carbon, the atomic number of oxygen is high compared to the hydrogen. So CO2H will get the more priority. So second priority will get the CO2H, and then the CH3 will get the number 3 priority, and number 4 will be getting the hydrogen. So this is the number 4. So I didn't put the numbers, but I need to put the numbers here. So here the number 4 will be the hydrogen. So according to the rules, like when you see the molecule, from the front side, okay, and if the number 4, okay, the group that is in the back side, when you're viewing the molecule, and if that priority of that groups in the anti-clockwise direction, so the name will be coming the S. S means sinister. Sinister means left-handed. Okay, so it is a left-handed molecule. So here chlorine to CO2H to CH3, it is coming in the opposite direction. So it is called the sinister or the left-handed molecule. And when you take the mirror images of the same compound to the, okay, so that another compound, you can see it is completely mirror images of this molecule to this molecule, okay. So in this case, you can check the tetrahedral carbon attached with the chlorine, CH3, CO2H and hydrogen. So chlorine will get the number 1 priority, then CO2H will get the number 2 priority, CH3 will get the number 3 priority, and hydrogen will get the number 4 priority. So when these are the, so in the priority order, if you just put the direction, it will be coming in the clockwise direction. So clockwise direction, it means the name is the rectus. Rectus means it is a right-handed molecule. So the molecule is the right-handed, and so that, okay, the priority order of the groups in the clockwise direction, and you are viewing the molecule from the top, and hydrogen in that, okay, the fourth position, okay, fourth group, then in the back. So when you view the molecule fourth in the back positions and you see the molecule in the priority order, like in that clockwise direction, so it will be coming the R. R means rictus or the right-handed. So this way, so this kind of formula, it is called the Flying-Wedge formula. So the Flying-Wedge formula, any molecules come, and if that fourth position, they are in that back, and if you see the molecule in the clockwise or the anti-clockwise directions, you can keep the nomenclature. If it is a clockwise direction and fourth in the back position, it is a R. If that it is a anti-clockwise direction, fourth in the back position, it is a S, means sinister. So it is a left-handed, and if it is a clockwise direction, it is a right-handed. Thank you. Thank you for watching.